Hello, Math 006. This lesson is from 10.8 and 11.1, and it's all about the complex numbers and quadratic equations. Just as a review, quadratic equations are equations whose highest degree is a 2. So since x squared is the highest exponent, these are all going to be quadratic equations. What we're going to do is take these first three problems and we're going to solve them algebraically and graphically. Now, keep in mind to solve these algebraically, what we have to do is start by factoring. Well, we know that x squared plus x minus 6 factors into x plus 3 and x minus 2. And then using that principle of zero products, we set each of these factors equal to 0. And then we solve for x to get x equals negative 3 and x equals 2. That tells us where this graph will cross the x-axis. So at negative 3, let's say 1, 2, 3. Let's say that's right there, and 2 would be right here. That means we would have a quadratic, which is going to be the graph that's shaped like a U. Not the best, but you can kind of get the idea. It would look like that. Go ahead and try the next one. We can see here that this one factors to x minus 3 times x minus 3 equals 0. And then we let that be equal to 0, the factor of x minus 3 to get x equals 3. That means it's only touching the x-axis in one spot at the value of 3. So to write their solutions for this first one, we would say that the solutions of this, because if we have to solve it, would be x equals negative 3 and also 2. The second one, we just get x equals 3. Now this third one, we look at this expression on the left-hand side, x squared plus 1. We will notice that we can't factor that. We can't factor it. So therefore, we're stuck with having to draw this picture of the graph. Now what I want you to do is I want you to pause the video and use your calculator to graph it. You will see that when we graph this, we do get the picture of the quadratic. However, it does not cross the x-axis at all. This tells us that there is no real number roots or no real number solutions, because our solutions are the point where the graph crosses the x-axis. So the next question says, how many real number solutions can a quadratic have? You see here we have two solutions. Here we only have one solution. Here we have no solutions. So with this, how many can they have? They can have 0 solutions, 1 solutions, or 2 solutions. Can you have more than that? No, you cannot, because the highest exponent is a 2 in a quadratic. That means at most you can ever have is 2 solutions. Now, what we're going to be talking about is the complex number system. And if you pull up the notes on Play-Doh, you can actually click this link to watch a YouTube video about how imaginary numbers are real. Now, they're called imaginary because it is something where you have to kind of think abstractly, whereas here you can see those exact places where the graph is touching the x-axis. This graph here is still going to have solutions, you just won't tangibly be able to see where those solutions are. So what we're going to be doing is solving this in an algebraically aspect. So we're going to solve it very similar to how we solved other equations, where we're going to subtract the 1 from both sides, and then we get x squared equals 1. Well, to get rid of the x squared, we need to take the square root of, this would be a negative 1 here. And then in order to take the square root of both sides, we go like this. However, you might think, okay, this one goes to x. However, we're stuck here with the square root of negative 1. And as you may think back, you cannot have the square root of negative 1 because we don't want any negatives under a square root. So now, what we're going to do is talk about the number I, which is represented by the square root of negative 1 here. And the definition of this, the square root of negative 1 is in fact equal to the number I. And that's how we're going to simplify a negative under the square root. So looking at the next one here, we'll come back to this idea and we'll see how it's going to be used. We want to express in terms of I here. So when we have to look at this, we can simplify this into two things. Just like we did in the previous sections, we can split it into two separate square roots, the square root of 9 and the square root of negative 1. Well, we know the square root of 9 is 3, the square root of negative 1 is I, so we get the answer of 3I. Now 48, we want to think, okay, we want to think, how can we simplify the square root of 48? So you have to think back, what is the largest perfect square that goes into 48? And think, okay, it would be 16. So we can change this to the square root of 16, the square root of 3, and the square root of -1, which would be 4 times the square root of 3 times I. And the last thing I'm going to do is just reorder this slightly to give us 4I times the square root of 3. Lastly, actually, why don't you pause the video and try this one out on your own? Okay, you see here that we have to simplify this square root of -18. Well, that would give us 9 times 2 times that -1. So 5 plus 3i times the square root of 2. That's what we're going to be working with in this section. So now, there's two different ways to solve problems that look like this. Solve the equation by factoring and by using the principle of square roots. By factoring is what we did in Unit 2. So to factor this, we'd have to take x squared, I'm going to rewrite it, equals 36. We'd want to first subtract 36 from both sides because remember we have to set it equal to 0 before we can factor. And then this would factor to x plus 6, x minus 6 equals 0. Which in turn we get x plus 6 equals 0 and x minus 6 equals 0, and then solve for both of those to find that x is equal to 6 and -6. Now to do that algebraically, and by algebraically we mean using this principle of square roots. So what we're going to do here is take this, and once we have this x squared term completely isolated, we can then just take the square root of both sides, like this. And then when we do that, we're getting x is equal to 6. However, here we have to be very careful because we want to think what values are we able to substitute in for x that'll give us 36. And the answer is not just going to be a 6, but also, right, a -6. Sometimes you can see this written as plus or -6 written like that. The reason why this works, meaning this step right here, is if we come over to the right here and I have x squared. Keep in mind, the square root of x is equal to the 1/2 power. So by taking the square root of this, that's the same as multiplying it by the 1/2 power. And then we know from our exponents that we'd want to multiply those two exponents together. That would give us x to the 2/2, which is equal to x to the first power, which is just our x. So that is why that works. Okay, so for these next couple problems, we want to solve using the principle of square roots, meaning we want to use this approach right here. And there's two things. It says do not forget to include the negative square root, meaning plus and minus is the answer. And before you apply the square root, make sure the square term or quantity is isolated. So we have to make sure we completely isolate the perfect square over here. So let's go ahead and work through this first one together. First thing we have to do is completely isolate the perfect square. So we have 6x squared equals, and we have to add the 240 to the other side. Now, from here you could ask yourself, is this all a perfect square? And you say, no, 6 is not, so you need to keep going with this. So now we have to take 240 and divide it by 6, which would give us 40. So we have x squared equals 40. Now we can take the square root of both sides. So take the square root, take the square root. And now we get x is equal to the positive and negative of the square root of 40. However, what you want to do is always simplify that. So think, is there any perfect squares that go into 40? And you think, yes, there is, because 4 goes into it. So 4 times root 10. So x is equal to positive or negative 2 root 10. And this would be your solution for this problem. Okay, what I have here is I took this part of the problem right here, the original problem, and I just graphed it. So I typed x or 6x squared minus 240. I had to alter the window a little bit because negative 240 would be where it's going to be crossing the y-axis. But you can see the shape of this curve here is a quadratic. You will notice that where it's crossing the x-axis, it does not fall on those tick marks, which means that you're not getting an integer as a solution, which we see right here. Now you'll also notice that there isn't an I I in this answer, which is why we do have two real solutions here. So you can always check this using your calculator. Another way you could do it is you could take this value right here and substitute it in for x, and both the positive and negative of 2 root 10 would make this statement true. Okay, I'm gonna get rid of this so we can try again. All right, so actually let's actually look at number 5 together, and then I'll let you try a couple of these on your own. So the first one, number 5, we want to subtract 4 from both sides, and when we do that, we get 9x squared equals a negative 64. Now here you could divide both sides by a 9, but from this point you'll notice that this whole thing is a perfect square, so you could stop there. But just to keep it consistent, I'm going to divide a 9 on both sides. So we get x squared equals negative 64 over 9. That doesn't divide out evenly, so I'm just going to leave it like that. Now we want to take the square root of both sides. Now, on the left-hand side, we get x is equal to, again, you always want to use the plus and minus. Now we have a negative underneath that. So we can break this into negative 1, and then we also have a negative or a square root of 64 over the square root of 9. Now to continue simplifying that, we'd get x is equal to positive or negative, square root of 64 is 8, square root of 9 is 3, and then the square root of negative 1 is I. So it's a positive or negative 8/3 I. Since there is the I in the answer here, that tells us that this quadratic would not cross the x-axis at all. So what I want you to do is go ahead, pause the video and check this out to see, graph it, make sure it doesn't cross. And then I also want you to work through these two problems. Now these ones are a tad bit different in the aspect that the base of the exponent has two terms, but we do the same thing. You take the square root of both sides. So go ahead and try them out and then unpause the video when you're ready. Okay, just to make sure you're on the right track. So right away, we take the square root of both sides since this already is going to be a perfect square. So we get x minus 3 is equal to plus or minus the square root of 12. Add a 3 to both sides, so we get x is equal to 3 plus or minus the square root of 12. We know the square root of 12 will simplify like I did here, so we get an answer of x is equal to 3 plus or minus 2 root 3. This is typically the order we'd write it in. We'd put the radical term second. Now again, since there is no I, you would see that when you were to graph this, if you would do x minus 3 squared and then a minus 12 or graph a 12 in a different one, you would see that it does have an x-intercept because there is no I here. So once you get this problem good, make sure you go ahead and try number 7. Okay, looking at this next one, we take the square root of both sides. We get 3x plus 1 is equal to plus or minus the square root of 15. Now keep in mind, square root of 15 does not simplify at all because no perfect squares go into that, so we can't do anything more with that. We have to still continue to solve for x, so subtract 1. So we get 3x equals negative 1 plus or minus root 15, and then we have to divide everything by 3. You will see I wrote it underneath each term separately here just to see if anything simplifies. If it would simplify here, you'd want to. We cannot simplify these because this is underneath a radical where this isn't. You'd only be able to simplify this with something outside. Since nothing simplifies, and I'm going to rewrite it as just one fraction. Again, no i's, meaning it will cross the x-axis. It's just not going to cross on an integer. Okay, moving along to the next page. All right, I want you to go ahead again and pause the video, and I want you to try out 8 and 9. Okay, for number 8, we're getting 5 over 2 plus or minus I times the square root of 6. Here's a case where we can do some simplifying, which is why it's important to divide each term separately. Number 9, we're getting x equals 9 or 1. Whenever you're getting integers like this and no i's or square roots or anything else, that tells you that this would have been factorable. So if we would have squared x minus 5, so x minus 5 times x minus 5, move this 16 over, we would have been able to factor that to easily solve for that. But this is also the way you could have done it, and you can see my steps throughout the problem. Again, if you have any questions on those, please either take a video or a screenshot or whatever you need to do, and please reach out and ask for clarification. Now what we have is 3 application problems here. Now, we're going to work through these application problems the same way, which they're giving us a formula, and we are substituting values into it. I'll work through one with you, and then I want you to try the others. So the formula S equals 16t squared is used to approximate the distance S in feet, so S is distance, how an object falls freely from rest in t seconds. So t is in seconds. How long does it take? So which variable you want to ask yourself represents how long would it take, and that would be t, so we need to find t, to fall 740 feet. So that tells us that this 740 feet, that's going to be our S here. So our S is 740 feet, whereas the T, we are finding the T. How long? That's representing our T. So it's important to recognize which value you're solving for and which one are you substituting your number in for. So we have 740 equals 16t squared. So we want to work through this just like we've worked the other problems. So we want to divide both sides by 16. Oops. Divide both sides by 16, and you can attempt to divide it out. If you do 740 divided by 16, you will get a decimal. So we're going to leave it just like that for now. And then we're going to get, so let's rewrite this as 740 over 16 equals t squared. Now we can take the square root of both sides of this. So when we take the square root of 740, you'll see that we're also getting a decimal. Since we're talking about an application problem, and also this problem tells us to round to the nearest tenth of a second, we're just going to type this whole thing in our calculator to get the exact decimal. So the square root of 740 divided by 16 is going to give us, it's giving us, let's see here, t is approximately the plus or minus 6.8. Now, what we have to think about is, do we want plus or minus? We want to talk about the time it takes the object to fall. Could it take a negative 6.8 seconds? We think no, that wouldn't make sense. So we don't want to include the negative here. So we can say approximately 6.8 seconds would be our answer here. So now what I want you to do, pause the video, read through 11 and 12 and see how you do with those. Okay, looking at these two problems here, we have this equation here that we're looking at. P represents the unit price, X represents the quantity in thousands, and it tells us the price is $11 per pair. So that's the price. We're finding X. Substitute the values in. I'm moving my negative X squared to the left to make it a positive, which means I need to move the 11 to the right. X squared equals 36 plus or minus 6. Well, we don't want the negative here, so we're using 6, and it tells us in thousands, so the demand is 6,000 scissors. The next one, we have this formula here. It tells us that P are the originally invested, A is the how much money's in the account, and R is what's compounded. We want to find the interest rate R, so that's what we're trying to find. And if we started with 2,500 and we go up to 2,717, that 2,500 was the original principal. The 2,717 is how much we have in the account, and we substitute those values in. We have to isolate this perfect square factor first, so we divide both sides by 2,500, take the square root. That becomes plus or minus the square root here. We're going to evaluate that eventually, but we're going to leave it like that for now. We still have to get the r by itself, so we subtract 1. So we have to do -1 plus this and -1 minus this, which is going to give us these two values here. However, we don't want the negative, so we're just going to go with the r equals 0.04. And if we were looking for the percent, we'd move the decimal over 2 places, so we can also think of that as 4%. So you just want to be careful with how the question is asking it. Okay, that's all I have for this video. That's 10.8 and 11.1. And then after this, you only have one video left. Good luck on the homework and have a great day.